All right, so now we have the factoring the special products here. So really quickly, note A and B are not the same A and B in the standard form equation, okay? So we have the difference of squares and the perfect square trinomials. So let's take a look here. So first, you want to make sure they're in standard form. So like this one, it's x squared minus 9. So pretty much what's happening here is you're seeing something like this, y equals ax squared. There is no bx, and then it's minus c. So that's what you're seeing, something like that, ax squared minus c, okay? And ax squared is going to be a perfect square, and c is going to be a perfect square, and then you're going to have a minus sign. That's why it's called the difference of squares. Okay, so but first you go to the, make sure it's a standard form, so ax squared plus bx is 0, so we don't worry about it, and then plus c. Factor out a greatest common factor if you can, so these do not have anything in common. Now we're going to look for our special factors. So this one is going to be a difference of squares here. All right, so in this case, here's what you do. I see a perfect square at the beginning, I see a perfect square at the end, and I see no b value, and there's a minus sign. So automatically I try the difference of two squares. So here's the formula. So the first term is squared. So let me kind of show you what this looks like. So that's a squared. And the second term can be written as a squared term. So minus, and then 9 is actually 3 squared. So this, in essence, a is x, and b is 3. Then we just plug them into this formula, a plus b, a minus b. So a is x, plus b, so plus 3. And then a is x again, and now it's minus b, so minus 3. And there's your answer. Okay, so that's how you do it. Now, pretty much what I do is once I see the perfect squares, I do the same thing. I just take the square root of that and get x, the square root of that and get 3, and I write it twice. Well, the first one's positive for me, the second one's negative. It really doesn't matter which order you put it in. Okay, so these first 3 will all be similar to this formula here. All right, so let's go through these steps. First off, it's in standard form. There's just no b value. There is no greatest common factor. 16 and 25 have nothing in common. This has x, this does not. All right, now I'm going to look for the special factors. So this is a difference of two squares. First thing I notice is that 16 is a perfect square, x squared is a perfect square, and so is 25, and then I have a minus sign, so that's the difference of squares. So the square root of 16 is 4. The square root of x squared is x, and the square root of 25 is 5. So I write it twice, and then the first one I always make positive, and the second one is negative. Okay. Now, if you want to follow the formula here, like to get the a and the b, square root of 16, this is, so the a is 4x, and the square root of 25 is 5. And then you can see that this is a, and this is b. But I just go straight to the answer. All right, let's take a look at this last one. So for the last one here, is it in standard form? Yes. Is there a greatest common factor? Actually, there is. 36 and 9 are both divisible by 9. So 9 times 4b squared is 36b squared, and 4 times negative 1 is 9. All right, now for me, perfect square minus a perfect square. So the square root of 4 is 2. The square root of b squared is b. The square root of 1 is 1. First one for me is positive, the second one is minus. And there's your answer. Okay, so you're always going to see me square root, plus, and minus. All right, now we have the second one, which are perfect square trinomials. Okay, so it's very similar to the previous one, but this time what you're going to look for is the pattern you're looking for. You're going to go from a perfect square, and then you're going to have a middle. It's going to be positive 2ab or negative 2ab. And this is, I'll show you how to do this right now. And if this trick works, you can use it. If it doesn't, then it doesn't work. You have to factor it another way. So let me show you how this works. So when you see a trinomial, if you see the first term is a perfect square, because x squared is a perfect square, and you see the last term is a perfect square, 49 is a perfect square, you take the square root of each one. So the square root of x squared, actually, before that, let me actually go through the steps, because that's one thing I need to make sure I do. Is it in standard form? Yes. Is there a greatest common factor? No. So now I'm looking for the special factors, and this is a perfect square trinomial. Perfect square, so the square root of that is x. The last term is a perfect square. The square root of 49 is 7. Now, to see if it's one of these right here, here's what I do. I do x times 7, so I multiply them. X times 7 is 7x, and then I double it. So 7x doubled is 14x. So that means it is a perfect square trinomial. Use the middle symbol, put it in parentheses, and square it. And there's your answer. Okay. Now, you could do the x method on that. It would work out the exact same way. You get x minus 7 times x minus 7. Then you would write it as x minus 7 squared. But the shortcut pays off when the numbers get bigger. So let's take a look at our next example here. All right, so for our next example, once again, I have, is it in standard form? Yes. Is there a greatest common factor? No. Let's look for one of these special factors. So I see 3 terms. So I look at the first one, that is a perfect square. I look at the last term, that is a perfect square. So I'm going to take the square root of the first term, which gives me 7x. Take a square root of the last term. Square root of 9 is 3. Now, before I write it out and make sure it's correct, I'm going to multiply it. 7x times 3 is 21x. If you double 21x, you do get 42x. So therefore, you use this middle symbol, and you square it, and this is your answer. And if you're looking for a way to verify this, you could write 7x plus 3 times 7x plus 3, FOIL it out, and you'll get this answer here, this trinomial. All right, let's try this next one here. 25x squared minus 80x plus 64. Is it in standard form? Yes. Is there a GCF? 25, 80, 64? No. Is it a difference of squares or a perfect square trinomial? Well, I see 3 terms. First one is a perfect square. Last term is also a perfect square. So we're going to take the square root. The square root of 25x squared is 5x. The square root of 64 is 8. So we multiply them. 5x times 8 is 40x. 40x doubled is 80x. So it does check out. We use the middle symbol and we square it. All right, and those are the shortcut formulas. You may need extra practice on those, so just keep practicing. Now let's take a look at a couple examples on the bottom, okay? And see if we can work through these. So, once again, steps of factoring. Is it in standard form? Ax squared plus bx plus c. Yes, it is. I see 3 terms. The first one is a perfect square. The last one is a perfect square. So I'm going to try to take the square root of the first term, which is 2m. Square root of the last term, so the square root of 49 is 7. So I multiply them. 2m times 7 is 14m. Double it, and 14 doubled is 28. Use the middle symbol. So this one was one of those perfect square trinomials. Okay, now if it didn't come out to that, then you would have to factor through other methods. Okay, second one. Is it in standard form? Yes. Is there a greatest common factor? Actually, there is. 32 and 2 are both divisible by 2, leaving me with 16x squared minus 1. Okay, now, do I have a special factor? Yeah, this is a difference of 2 squares, right? So I'm going to put a 2, parentheses, 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 parentheses. 16x squared, these are both perfect squares, and 1 is a perfect square, and there is a minus. So we're looking right here at the difference of 2 squares. So a plus b, a minus b. So the square root of 16 is 4. The square root of x squared is x. The square root of 1 is 1. So we have 4x and 1 on each one. Like for me, once again, for me, it's just the positive is the first one, minus is the second one. If you put minus first and positive second, it would not change your answer. All right, let's look at this last example here. Is it in standard form? Yes. Is there a greatest common factor? Yeah, there is. 18, 24, and 8 are all divisible by 2. So 2 times 9x squared is 18x squared. 2 times 12x is 24x. And 2 times 4 is 8. All right. Once again, look for those special factors. If not, go to the x method. You could do the x method on this quite easily, but I do see that there's 3 terms. The first one is a perfect square, and the last term is a perfect square. So I'm going to write my 2 here just in case. We'll see. So the square root of 9x squared is 3x. The square root of 4 is 2. So 3x times 2 is 6x. 6x doubled is 12x. So I use the middle sign, and I square it. And those are the notes for the factoring of special products.